Yeah, I wanted to to read a little bit from Ursula Franklin's book. She has a really great paragraph in here which fits perfectly. She says, now, among all the infrastructures that port specific technologies in their industries, the infrastructures that support the preparations for war and violence are very powerful and deeply entrenched. You note that I do not use the word defense. This is quite deliberate because in defense, in the sense of maintaining territory and authority, if that had been the main policy priority, then other structures with other contents would have been developed. And what we see here is not a defensive capability except in the Orwellian sense of the exact opposite, which is that it is an offensive capability. And this is something which FOXACID, to answer that question, what is FOXACID? FOXACID is a system that the NSA uses. The Tailored Access and Operations Division redirects through vulnerable protocols such as HTTP. They redirect a user that they've decided is a target in some way to a system, which is a FOXACID server, so-called. And this server enumerates their web browser, or we'll just leave it to the web, but FOXACID and other programs like it are not limited just to the web. They basically enumerate the web browser, determine if there is a vulnerability, and then they exploit the vulnerability in the web browser. And this, of course, allows them to take control of the machine. In some cases, an operator will become involved, and they'll make decisions because it's a high-value target, or a so-called HVT. This works extremely well against everybody. It is much harder for them to use FOXACID against Tor users. Part of the reason is because you are required almost everywhere, not necessarily by law, but as a de facto policy, to have identification tied to your internet service. So when you browse the web and you have a vulnerable service, or when you use Yahoo's badly written chat client or whatever, right? Then they're able to target your home internet connection, know that it is yours, know that the identifiers like the IMEI on your cell phone, that they tie to you, and then they can tie that in as a so-called selector, which is then used to automatically target the person and then to break into their computer. And it can be completely 100% automated in some cases. So if you visit certain so-called terrorist websites, that might happen to you in a so-called untargeted manner. And this FOXACID program is, in my opinion, incredibly scary. And in fact, I understand a little bit more about FOXACID than has been disclosed in public, and I'm working on an article about it. But let's say that part of the US Constitution specifically talks about not quartering soldiers in people's homes. And this is something which, I mean, if we look to Jefferson, this is something which fundamentally is concerning in European states. If we look at the history of the United States, it's also concerning. The FOXACID system does the equivalent of quartering soldiers in people's homes, using other people's routers to beat the speed of light. If that doesn't make sense, I'll explain it in an article in the near future. But basically, if they can trigger on surveillance, and an operator is in Maryland, but the surveillance incident that is hit by a selector happens in Frankfurt, they can repurpose machines that are closer to the target to inject data to redirect a target to a FOXACID server somewhere else in the world. So they can automatically task a person for targeting in this way, and then they repurpose commercial home routers, essentially, to bounce packets. These are called diodes. That's actually never been disclosed in public before. So thanks for having a place for free speech. But that said, this is terrifying because it is like the military occupation of the entire internet. That's what this is. So this FOXACID, quantum insertion, these types of things, the quantum theory, the whole field of quantum programs, they are the equivalent of having soldiers all over the internet and checkpoints all over the entire internet, and then automating triggering of action. And in some cases, humans are completely cut out of the loop. So I hope that answers your question. But Tor is one of the only things, I work on the Tor project, so I have a bias, but I work on it because I think it's useful. It's one of the only things that actually stops this kind of targeting from succeeding automatically 100% of the time, because it becomes a statistical possibility for them to begin to target a person occasionally. I'm using Tails here. This is a live CD. 100% of the traffic goes over Tor. So whatever surveillance is happening at the European Parliament, whoever's doing that, they've got to break Tor first. So, I mean, FOXACID has a harder time with this, a much harder time, I think. And to the point about encryption techniques, There is a story of a Pythagorean theorist. He discovered irrational numbers, Hephaestus or Hephaestus. I don't speak Greek. Someone here does. It's the parliament, right? So someone does. But he discovered irrational numbers, and this upset the Pythagoreans so much that they drowned him at sea. The Iranians, when they filter the internet, they specifically block certain prime numbers from being transmitted. This is how they block Tor, or they did at one point, and they censor those numbers. We should not join the people who are famous for killing a man at sea and the Iranians' internet censorship programs and banning encryption. That's not a part of history we should be a part of. And I think that it's also, you know, when Mr. Heather discusses, you know, this idea about encryption being, when it's well implemented, that fundamentally it's sound, I think he's correct. I'm a little bit worried about some of the discrete log stuff. I'm a little bit worried about Diffie-Hellman and small modulus for modular exponentiation. Like I'm a little bit worried, but I think in general it's good. One of the scary things is when you talk with cryptographers about ECC crypto, some of them don't understand how the supposedly backdoored NIST curves are backdoored. They don't understand what those values are. You know, and there's this idea that we can have so-called nothing up your sleeve numbers, that is special values that you put into the crypto, and then you know how they're generated, so you know there's nothing up your sleeve. The problem is, what if what you need is a well-constructed number, and the thing up your sleeve is that you don't ever use a not up your sleeve number in that place. So this is a really, really tricky problem. And one of the solutions would be that if all the big brains at GCHQ and the NSA worked on solving it in public. I mean, there are just a few really incredibly smart people. Mr. Heather is one of them. This guy in the front audience here, he's like APT 0 right there. There are very few cryptographers that work in public that are open. You know, I mean, Arjen Lenstra, Mark Stevens, Ross Anderson, Stephen Murdoch. I mean, there's maybe a couple dozen that are really, really good and really dedicated to open research. And a lot of the mathematicians, a lot of the cryptographers, they work in these intelligence agencies in secret, and the public purse pays for their secret research, and it is kept secret potentially for all time until another Snowden comes along, basically. So fundamentally, what we need is to see a shift of that these defensive organizations that also have an offensive mission, that they should be split. Information assurance does not go well, I think, with weaponizing exploits. If you have to break into systems and you get all the bug reports from the information assurance side that tells you how to break into systems and how to fix them, you always have an edge for breaking in. But you also have an incentive to never, ever, ever fix the broken systems. And that's actually part of what we see with FOXACID and quantum insertion and other programs like that. Yeah, what we really need to understand is that bureaucrats follow laws until they decide to break them. And the thing we need to do is use mathematics to make sure that bureaucrats can't break the law. That's basically what it comes down to. Because if they will be able to abuse this power, that is, if they have a system for breaking into a computer, it will get used. The German police, for example, have this so-called state Trojan, and one of the police officers with access to that backdoored his daughter's computer in order to watch her. I mean, how many examples of that do we need to know that this is the wrong way to go? Because we are building these systems with that conflict of interest in mind, we fundamentally cannot win. We are using oppressive techniques and oppressive technologies, and we are unfortunately not building defensive technologies that are actually used in defense. And as a result, it means that we have transitive risks. You have a cell phone, right? And you have a cell phone, and it's on the same cell phone network that this guy in the front row can intercept with the gear that he has in his backpack, I would guess. That means that the same vulnerability trade-offs that we make, unfortunately, they are going to be used against you guys by people who are criminals. In fact, walking here, I noticed that there was a so-called IMSI catcher that my cell phone's baseband firewall picked up near the Japanese embassy. Maybe it was just a bug, but you know, this shouldn't be possible.